in our group. Okay, just for assignment chapter, no class activity. Okay. Hassan, you mentioned about the typo. Hassan, are you here? Maybe not here. The others, are you okay with the isomorphism theorem, the notes from e-learning? Yes or no? Yes or no? The notes, are they okay? No typo, right? No equations are all okay, right?
Prof, some symbol put in the square only.
Oh, Fauzia also.
Yes, and e-learning.
What about the others? Farah, are you okay with the symbols for chapter?
No. I have problem in theorem 3.2.
Oh. What about Ain? Chapter 3, is it okay?
There is some unclear one.
Can you recheck the PDF and try to send in WhatsApp group? Let's see. Okay, try to resend. The one that you show and you screenshot is okay in the e-learning. What about Sheham? Yours, is it okay? Oh, Sheham is okay. Okay, anyhow, while you're doing that, let me go through the chapter. Okay. Let me see if I have my e-learning here. Everyone has scanned your attendance. Chapter 3. Three 3.2. Okay, let me try and share. So this is the e-learning. This is chapter 3. Okay, that's chapter 3. Oh, forgot to make this black So, right. Which one that is not right? But this one was okay, right?
Prof, page 4, not okay.
Oh, page 4. This one.
Yes.
But this one is. Oh, this one.
Yes.
This one is still missing, right? Yeah. The element of, right? For this one. Just this. But the rest looks okay. This one is missing comma, right? The one hasn't shared is proof of first. Oh, the one you mentioned earlier. Proof of first isomorphism theorem. This is the theorem. This one. Oh, your fee did not come out. Okay. Hannah sent in WhatsApp. Let's see. .2. Okay, looks okay to me here. What about yours? No, Hannah. Page 4 is still. In my phone, phi becomes F in my phone. This is weird. It's okay. After this, take a look again. Show that page. This page. This page should be, and this one, Hannah. There's a inside. This is element of AB element of. Okay, this are all phi. Which one again, Fozia? Is this the only page?
Yes, Prof, this is only.
Oh, this is the only page. So now you can just see this first before we give you a new one. Hopefully the right. Okay, that's so phi of A times phi of B inverse is phi A, phi B inverse inside. Okay, and then you can, because it's a homomorphism, you put AB inside. Okay, so maybe that one didn't come out, and then the rest is just this. Okay, I will stop share now. All right. Okay, so we'll go with free abelian group. Now, free abelian groups, the properties of free abelian groups. they have many similarities with vector space. Okay, if you don't remember what a vector space is, go back to your linear algebra notes, right? A vector space is a non-empty set. It is closed under the operation, right? We have addition and multiplication by scalar. That is vector space. And there are 10 axioms for vector space, right? So go back and look back if you don't remember, right? The first one is it's closed under addition. So U, V in V, U plus V in V. It is closed in the 5 is under addition. The other 5 is multiplication or mix. There's an identity, there's an inverse, right? So those are the vector space. Now, we have a group, okay? And groups can be abelian or non-abelian. And then in this chapter, we want to look at what a free abelian group is. Okay, then we will deal with the rank of a group. We look at, like in the vector space, we have a basis, right? Here we also will have a basis. Okay, now let me read out the definition of a free abelian group. A free abelian group is an abelian group that has a basis. So you see, you have abelian group and you have a basis. Okay. Now, what does it mean by a basis? Let me ask someone if you can still remember what a basis is. Wally is connecting to audio. Hassan, if you are there, turn on your video. I haven't seen you. Amrina, are you there? Amtinan, you just said just now you are there. Okay, Amrina, who did you take linear algebra with?
Prof. Dr. Mohainia.
Okay, Dr. Mohainia. Okay, do you still remember about vector space? Yes or no?
I think no.
Maybe a little bit. Okay, do you remember what a basis is? What is the basis of, say, if you have a vector space V? Suppose S is a subset of V. Okay, Amrina? S is a basis if there are two conditions, right? What is it? Anyone can remember? S is linearly independent. Okay, the other one is S spans V. Right, this is what we learn in linear algebra. S is a subset and it is a basis if S is linearly independent and spans. Why it's having hot? Okay, and what does it mean by linearly independent? Okay, suppose S consists of U1, U2 until UN. then S is linearly independent if C1 U1 plus C2 U2 plus Cn Un is the zero vector of V, implies Ci is 0 for all I from 1 to n. Okay. If you have this combination, if you multiply each of these element in S by C, C is real number. If you have this combination, you add up C1 U1, C2 U2 until Cn Un equals 0. 0, I put it sub V because this V depends on the space. Okay, it can be a matrix, it can be a polynomial, it can be Rn, it can be functions. Okay, so it depends on the 0 vector.
Prof, Ci don't equal 0. You write equal or don't equal.
This one?
Yes,
Yeah. It
equal.
has to be equal 0. For linearly independent, they have to be all equal to 0. Right? For all. If any one is not 0, that means dependent. Ozia?
Okay, yes.
I will just show you one example after.
Okay.
S times V means for all Y in V, there exists. I use different coefficient, Ki in R, such that for all Y in V, so you have this V, you have this S, right? And you have this U1, U2, U3 until UN. So for all Y in V, if Y in here definitely is one of the U, say there is a Y in here. For all Y in this V, there is this coefficient Ki in R such that Y can be written as K1, U1, K2, U2 plus Kn, Un. Meaning, any element of V can be written as a linear combination of the vectors in S. So you have to use, and you have to remember this for also to look at the free abelian group. Okay, it has the same concept. So I mentioned in there, every element of the group can be written in one and only one way as a finite linear combination of elements of the basis with integer coefficient. Okay, so there is a difference in here that the coefficient for this particular chapter is not the real number. It has to be integer coefficient. So that is the difference between this and vector space. Okay. All right. So the next page is there is abelian group G I give you generating set X, okay, then it satisfies two conditions. Every element is uniquely expressed like this, but n, the ni there, I put that is in Z. So in this particular free abelian group, in this particular basis, this I replace over there with n and this with x, yeah? And this is in Z, cannot be 0, this is in Z. All right. And then the next one is, if it is equal to 0, then all the coefficient, they are all 0. This one. This is linearly independent. Okay, so I switch. Number 1 is actually spanning, number 2 is linearly independent. So in that case, I call X is the basis of the group G. I change the notation. This is the notation in linear algebra in the vector space. So let us write the notation for this one. So it's clear. Okay. Right. So I will write again. Accordingly, from the beginning, so suppose G is an abelian group. Suppose G is an abelian group and X is a generating set of G. What does it mean by a generating set? Generates, right? Like spanning in chapter 3. Generates means every element in G can be written as combination of elements in X. Okay, now the first one is, I'm following this, okay. For any A in G, for any element, non-zero element A in G, non-zero element A in G, okay. A is n1 x1 plus n2 x2 plus nr xr. Okay, for xr in x, no, the one is xr. So this one I can write x1, x2 until xr. Okay, for any A in G, A can be written as a linear combination of elements in X. And this is unique. This is unique. Okay, and it is a unique combination. What do I mean by presentation? Not combination, presentation. Presentation. You remember when you study linear algebra, when you have equation, system of linear equation, you have a unique solution, right? So you cannot have many solutions. It has to be unique. So there is only one way to write, and that is the basis. Okay, otherwise it might not be independent, it might not generate, or it might not span the whole thing. Okay. Number two, the fact that this is actually already say that X generates G. Okay, if N1 X1 plus N2 X2 plus NR XR is 0. Okay, for Ni in Z. Oh, I forgot to put Ni is not 0, Ni is in Z. Okay. So we don't want Xi to be different, to be the same. Then Ni is 0 for all I 1 to R. So this is generating set or generates the whole group. This is linearly independent. Okay. Okay, then with this condition, then G is a free Abelian with basis X. I didn't say that X is unique. A group can have many bases. Okay. This chapter is actually this very short chapter, but people will use free abelian groups and later on free groups to get the quotient of group and all those. Okay. Last class I wanted to share something from the last conference, but I forgot. I hope today I have the time. There's something I want to share. Okay, example. Let G is this. Suppose you had to show that G is free abelian. Okay. Then you had to find the basis. Right? So let me write X. This, what does it mean? You have to know how to write out the element. Try to write out the element of the set. Okay, so what is Z cross Z? You see, it's like a direct product, right? So you have learned this before. X comma Y. X, Y in Z. This is an infinite group because Z is infinite. Okay, infinite group because Z is infinite. You can have so many elements in Z cross Z. 1, -1, for example, right? You can have like this, right? Normally we call it XY, but this is ZZ. Because integers. So you can have 0, 0, 1, 0, 2, 0. You can have 0, 1, 1, 1, 2, 1. You can have 0, -1, 1, -1, 2, -1. You can have -1, 0, -2, 0, -1, 1, -2, 1, -1, -1, -2, -1. Okay, so these are all elements. Okay, so give me a generating set. The easiest one would be this, right? Because any other element in here can be written as a linear combination of these two. For example, because I choose this, right? Actually, and this two, this and this. You can go and get the others from this. Suppose you want to get this, that will be 2 times this plus this, right? If you want to go to here, you will go -2 times this and then negative that, right? So you can reach all of them. So is the basis. Okay, so I will delete this word n. Okay. Now I give you 3 minutes to write out before I give the answer. Okay, 3 minutes from now. Let's see what you can write in 3 minutes. You have to show 2 things. Okay, finish my coffee. Saya dah tak perlu lah benda bawah kan. Okay, how many more minutes? 1 minute. Oh, lama 3 minit. Sini padam je. 10 seconds. Okay. All right. Okay. So the first one is, what is the first one? Independent first or in the spanning? Okay. Okay. So let X, I don't want to use X. What did I use? A. Let A be, I can use, I don't want to get confused with my definition. XY, X1, Y1. Where is my notes? My notes says X1, right? X1, X2, oh, cannot use X1, X2, then you'll get confused. And N. Yes, I can do X1, Y1, right? XY, yes, I can do this. Let A equal XY in Z cross Z, right? Okay. Okay, we want to show that any A can be uniquely expressed in that form. Okay, so A equal this one, right? This one is now the, this one is now the X1, X2 in the definition. Okay, so I use N, right? N1, 1, 0 plus N2, 0, 1. Okay, and N1 and 2 is actually integer. Okay. Now what you have to do is to find N1 and N2. And you have to show this exists and is unique. Okay. This is actually a very easy question because straightforward. You can get the answer, right? So you go back to the system of linear equation. You will write this one is N1 well, straightforward, right? You add, you multiply and you add, you will get N1 and 2, right? Okay. So N1 is X and 2 is Y. And in the first place, X and Y is in here. So that means X, Y is actually integers, which is in integer. So if you give me 2, 3, for example, you remember this drawing? Erase already. If I give you 2, negative 3, easily you will say this is 2 times 1, 0 plus negative 3 times 0, 1. Because this depends on this, right? Straightforward. Okay, and you will not get 2 answers. Whatever you give me XY, that is my N1 and 2, right? After this, let's take a look at 2 other examples and see not the easy one, right? Okay. Next part is, okay, so X is a generating set, and I just put that. Okay. And the, what is it? The presentation is in here, right? Okay. The second one is, we let n1 1 0 plus n2 0 1 equals 0. What is the 0 in Z cross Z? 0 0. Okay. So the 0 in the group G, you have to know the 0 in the group G is the 0 in Z and the 0 in Z. Okay. Again, this is very easy, right? When you add this, you get n1 and 2 is 0 0. Apply n1 equal n2 equal 0. Okay, so this means it's linearly independent. All right, so the next extension of this example is to extend until n copies. Okay, to extend until n copies. So I will change. I am not going to give the proof because they are very similar. Dot, dot, dot. You know, when each of you will be having your thesis or dissertation, right? You have to know when it's dot, dot, dot down here. And you have to know when it's dot, dot, dot in the middle. This one is a sequence down there, right? This one, this one. This one is you repeat. You repeat. I had Viva last time, the examiner. So that's the problem. In the whole thesis, the student cannot differentiate in between down there or in the middle. So when you type, whether you use Word, so you have to use the equation editor or math type. If you use LaTeX, it's slash the C dot, right? Then the other one was, what is it called? Best difference. Okay. What do I want to show? Show that. Right? Oh, okay. Equal 1 0 dot 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 0. Accordingly, dot dot dot. Second one is the second one. The third one is the third one at 1. You know what is this called? Anybody know what this is called? The 3 dots? I'm asking everyone now has degree in mathematics, right? There is a name for that. Anyone knows or nobody knows? If you don't know, then you can show this. If you
All-
know, you
All elements 0.
no. What does it mean by dot dot dot? Like 1, 2, 3 dot dot dot. That is a name. Do you know or you don't know? I will just laugh. The name is. Do you know? No. You try and Google. Am I right or not? I'm teaching you something wrong. Let me see. Ellipsis. Yeah. The ellipsis or a Unicode, also known informally as dot dot dot. That is not my name. Yeah, that is in here. It's a series of usually 3 dots. It's not 2. It's not 4. 3 dots. Yeah. Intentional omission of a word, sentence, or whole section without altering the original meaning. This is in Wikipedia. Today you learn a new word. Ellipsis. So when you write, you will be teachers or lecturers. Don't just put 4 dots. It's dot 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 3 dots. Ellipsis. Okay. Okay, because we will have so many ellipses here. Dot 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 until dot 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 the end point. This is a basis. So this is a free abelian. The proof is just the extension of just now. Instead of x1, x2, you have x1, x2, x3 until, if you have n of them, xn, right? And the rest, they are very, very similar because it's just multiplying. Okay. Let's see. I won't be giving you any exercise because this is too easy. It's too easy. I already gave you the answer for number 2, more or less, but oh wait. I'll give you a hint. It's not really this. If G and G prime, I'm looking at the exercise. If G and G prime are free abelian groups, then G cross G prime is also free. It's very famous exercise actually. And then you can extend to N. Okay. Okay. I give you a hint and I just said I give you a hint and I will give you the answer. Okay. So you start with let G and G prime be free, right? Abelian. Then let X and X prime be the generating set or basis, right? Of G and G. So how do you want to show? So show X cross X prime is the basis of G cross. Today I said I don't want you to do exercise. The next time I will say I want to see you write it down. Just try and write down of this proof. It's quite straightforward because this is a generating set. You can let x1, x2 until xn, right? And then you have x prime, again, another one. And then the comma, the pair. And then you use the definition like before. Okay, write that out. I think probably, yeah. It's a good exercise actually to see whether you can write down, because when you're showing independent, you will have two different sets of system, because one system come from here, one system come from here, and then coming from here will be a pair. Okay, and then the next one is to extend. I told you I want to give an example. I give you another 3 minutes to try and do number 1, part 1. Decide whether the following is a basis. Okay, 1, part 1. From now, 3 minutes. Probably 1 minute you're done. If you already get the answer, just tell me. I will stop the time. If it is a basis or not a basis. I haven't heard anything from Hassan today. If you are there or not. Hassan? Cannot hear you, Hassan. What happened? Your internet or what?
Proof, but I have internet.
What? Your internet or what?
Yeah.
Is it me or the others can hear? Lava, can you hear Hassan or not?
No problem.
No, Hassan breaking. You type, Hassan, what you said? Type, Hassan, don't talk. I cannot hear. I cannot understand. Type in the chat what you said. Okay, anyone done? Anyone want to try? Oh, already 3 minutes. Okay. Yes or no?
Yes, Prof.
Yes, meaning what? A basis?
Basis, yes.
Okay. What about others? Yes or no? Ahmad, Hussein?
It's not.
It's not. Why?
Yes. No.
What is the question again? Z or Z, right? You see, if you draw 1, 1 is here. -2 is here. Okay, if you draw, you see the same line. So when you multiply 1 with an integer, you add 1 with another integer, it will fall on that line only. So it cannot span the whole Z cross Z. So it does not satisfy. And 1 is actually depending on the other one. Because you will see that this is actually this, right? Right? This is actually 2 times that, -2 times that. You bring 1 to this side, you will get or you bring this to that side. Right? Okay, so this shows that my n1 is 2 and 2 is 1, in which n1 x1 plus n2 x2 is 0. And this implies this is not 0, right? Because you have this. So this is one way to show that it is not independent. So it's not a basis. If you don't show this way, because I can see this way, if you don't use this way, you will write n1, 1, 1 plus n2 is 0, 0. Then you solve, right? This is the normal way. So you will write n1 minus 2n2 is 0, n1 minus 2n2 is 0. Right? So this says n1 is 2n2, right? Which is not necessarily be 0. So there are many answers. I just choose n1 equals 2 if n1 is 2 and 2 is 1. Then I get one answer. But you can also choose n1 can be anything and 2 can be anything else. Then it will give you infinitely many solutions, which is not 0. So the homogeneous system of linear equation has many solutions, if you remember in linear algebra, right? So in this case, it's not 0. We want it to be unique, which is 0. So in case, no. So you can stop and say it's not the basis. Another way is you can say that when you multiply this and you equate to x1, x2, say, you will get not a unique solution also, right? You remember? Even if this matrix, you take the determinant of this matrix, you get 0. This is 2 by 2. Determinant is 0. So if you check your linear algebra, that means the solution is not unique. Okay, the solution is not unique. So this does not satisfy the first condition. Okay, there is another reason. Okay, so that is part 1. You can try quickly and see the others, but remember, try all, yeah? 2, 3, 4. We'll discuss that in the next class on Wednesday, and we do some theorems. And remember that our N1, N2 has to be integers. Okay, doesn't mean that it has a solution in real number. It has to be integers. So if you get a solution but not integers, you solve the system of linear equations, it's not integers, then it is not a basis. All right, any question? I hope we'll resolve that page 4. I don't know why I have to look at the original one. Okay.